Hello, this is Trouble, and I'm here to show you how to use comparators. So, firstly, comparators have a signal strength that they can pass on to another redstone component, such as redstone dust here. So we start from 15, we go down to power level 13, you can see in the upper left-hand corner. And if you use a comparator here, then it will just continue that signal strength. It's kind of like a repeater, but it keeps the signal strength going. And so if you use two comparators, same thing, it'll just keep the signal strength coming in from the back. Same as repeaters, they can read it through a block. And another interesting thing about comparators is that they can read from containers or other various objects. I'm not going to list all those objects, but you can find those elsewhere. But I'm just going to use cauldron for the sake of example, and also sometimes redstone blocks. Comparators can read these containers through solid blocks. So if I were to not do anything here, then it does nothing. So yeah, if I were to place this here, but it can't read it through, say, a piston, which is not solid block. Okay, so if we have a redstone dust here, and we have a container behind it, the comparator can, the comparator has a choice to make, either read from the redstone dust or read from the cauldron. So if I had cauldron here, power level 1, it'll read 1, but if I had a redstone dust here and power it with this redstone block to power level 15, comparator will override that and it will now have 15. The reason why I'll get to in just over here, but it has to do with which, like both of these are technically the comparator is reading from both the block and this cauldron here, but the redstone dust has a higher value. So the comparator is going to take that. And so over here, I'll demonstrate that a little bit more explicitly. This cauldron, level 2. This cauldron, level 1. As you can see, the comparators here read level 1 and level 2. And this comparator here is reading power level 2. And yeah, as you can see, all it's doing is it's looking at the highest, and it will just take that and then push it forward. Okay, a weird thing about comparators is that normally you can't put a observer and expect to get an output like this. Nothing's happening. However, if you have two observers, power them at the same time, then yeah, as you can see, simple. So yeah, that's how you short pulse with the comparator. Okay, so here is something that trips people up is the compare mode of a comparator. It's really simple, so let's just explain this. We have a power level 1, and we would expect it to output a power level 1, except that we have a power level of 14 going into the side. So what does this mean? The comparator is going to look at the value behind it, and then it's going to compare that to the value coming in from the side. And so if the power at the back is greater than or equal to the power coming in from the side, it will take the power level from behind and it will go forward. So yeah, since 1 is not greater than or equal to 14, then it outputs nothing. What if I were to put a redstone block behind it? Okay, so we have a power level 14 and it's comparing that to power level 15. 15 is greater than or equal to 14, so it's going to output 15. Make sense? Okay. And so the sides of a comparator cannot read like a comparator back end can. So for example, I have a power level 1 and I have a power level 2. So same as over there, since 1 is not greater than or equal to 2, you would expect it to not output anything. So yeah, this obviously doesn't work. Same thing if you put a block in between it, same deal. Okay, so there are exceptions, namely the redstone block. So if you put it right next to the comparator right here, then it will output 0. So it's 1 and now it's 0 again. Okay, and so you can also use a repeater here, but you can't power the block next to it. So yeah, this is also another critical thing to understand, is that you have to put a direct input into the comparator in order for it to use the compare mode. And so yeah, you would expect this to be 0, but it's outputting power level 1. But if I put the repeater right next to it, it will turn off. Okay, so now we have the subtract mode. This is also very, very important that you understand this. So just like the other demonstrations for compare mode, the same properties for how to use it is basically the same, except its behavior is slightly different. So we put in a power level, and we have another power level going in from the side, except the comparator will look at the new power level coming in from the side here, and it will try to subtract it from the one coming in from the back. And so you can see here that we have a power level 14 and we have a power level 15. Okay, and it will take 15 and it will look to the side and subtract, and so we'll get an output of 1. So 15 minus 14 is 1. Okay, and so this is the same for compare mode. If you have two inputs coming in from the sides, then the comparator here will actually look at the maximum. So we have a power level 3 coming in, and it will look to the sides, and it sees a power level 2, and it sees a power level 1. Okay, and since 2 is greater than 1, it will subtract from 3 the power level 2. So 3 minus 2 is equal to 1. If we were to destroy this comparator real quick, then the only one coming in from the sides is this power level 1. And so 3 minus 1 is power level 2. Okay, this is also very critical. So if you have two comparators going into the sides, or two of any component really, it'll look for the maximum of the two. Okay, and so those are the basics of comparators. And now let's look at some slightly more advanced stuff. So if you have a block in between a container that it's reading from, then what you can create is a comparator update detector. Now, this comparator should not be turned on at all. It doesn't have a block behind it. There should be a block right here that is a container, but there's not. So if we were to update this comparator by giving it some, putting a block next to it, then it will turn off. And since the observer will detect that it turns off because this rail will turn off, then it will trigger this piston to pull it back up. And then the comparator will realize that there's a block behind it that's a container, and it will turn on again. This observer will again detect that and push it back down, creating a cycle. Okay, so interesting things. This comparator update detector is very useful because you can detect changes in a container's fill state. So if we were to have items going into this hopper or into this dropper, then, well, the comparator will detect that. And since it's directly powering this dropper and thereby this hopper, the observer can detect the changes and yeah, it will clock. So let's just test that, put an item in here, just water bottle. Yeah, so you can see the item is moving back and forth from the dropper to the hopper and back. And each time it moves, the comparator is detecting that, and it's changing its state, and observer keeps detecting that. Okay, there we go. It's a bit noisy, so turn that off. Okay, so next thing is we can put a solid block in between this comparator and another container here. So let's put a cauldron. Yeah, it'll detect it. And not only that, if we put a water bottle in it, it'll detect that. Pretty cool. But if I were to break this and then change, yeah, nothing happens. See? Okay. The reason why is because the comparator will do a check. It'll look at the surrounding blocks, all the ones that can possibly uh, change the state. And since this cannot possibly change the state because there's no block in between it, then it doesn't care. But if there was a block in between it, even though it's facing, even though it's facing this way, not this way, it will still think that this block has a chance of changing its value, and so yeah, it will take the update. Okay, so now let's go to advanced computations here. So what do I mean by advanced computations? I mean simple arithmetic, which is surprisingly difficult, but it's easy once you get the hang of it. So what's this here? So we have a power level 15 and we have another power level 15, and in the middle we have two cauldrons, one with 1 and one with 2, and we output here 3, and this is not a coincidence. So what's going on? I will put on the screen an equation, and since I'm not me from the future, I will try to explain what I wrote in the future. Okay, so here we have a power level 15. I'll call that M for maximum. And we subtract from that two numbers. We subtract 1 and 2. So in total we subtract 3. And then we have M again. And we subtract from M this number that we just computed. So M minus the quantity M minus 1 minus 2 should equal 3. And so I'll put on the screen a formula. It should make sense if you know algebra. Okay, so there are limits here. You can't just add any number if you have a limited starting number. So for example, if we have 15 again, and we subtract from that 15, it will be 0. And so if you subtract anything from 0, a comparator cannot have a negative value. And so it will just output 15, it won't output any more. And yeah, this is an issue if you want to do something, a little bit more complex than adding two numbers that are less than 15. So, well, what can we do? We have something that we can do here. This is not something that would be considered normal. You have a power level 15, you're subtracting it from this comparator, and out here I'm getting 14. And so you're probably thinking, wait a minute, shouldn't comparators have a maximum value of 15? Well, they should, except this is not a normal furnace. Inside, I have stacked uncraftable potions, which are unstackable, and that means that the container has a higher value for the comparator than what would normally be possible in Minecraft. And so this is what I'll call a supercharged container, where you have some abnormally high value that you can read from. And so the thing is that you have to remember that redstone dust can only have a maximum of 15. So you can't just have a repeater here and, I don't know, if I were to delete this redstone block real quick and just have this and put the redstone block back here, then yeah, it's not going to output 14. The reason why is because redstone dust will just go up to 15 and no more. Okay, so yeah, we're at 14. So why is it 14? With intuition, you'd expect this to be 15 times 2 because there's one stack in each slot, and one stack in each slot would mean that there's a power level 15. So we have technically two stacks per slot, so we'd expect 30. However, we're subtracting 15, we'd expect 15 to come out, it's actually 14. And so here's the formula, I wrote it down on a sign. So it's 14 times n being the number right here, plus 1. And yeah, this is just a basic formula. If you want to do more precise values, I'm not going to go into that right now, maybe in the future, but yeah, if you just want multiples of 15, then yeah, that's how you do it. Okay, so yeah, again here it's a proof of the formula. You have 3, so if it were 15 times n instead, then we'd expect power level 45. So we subtract 15 twice, and so we'd expect power level 15, but we get 13. And it's not 14, mind you, it's 13. So yeah, 14 times 3 plus 1 is going to give you 15 plus 15 plus 13. That makes sense? Okay. And finally, the last thing I want to do before I go into some even more advanced stuff is a memory circuit. So let's say I put a redstone block here. Okay, so we can read from this and it says 15. And the reason why is because the comparator will just keep on going around in a loop and the power level will be maintained until we do something to it. So let's say we put in a water ball into this cauldron. It will keep subtracting from the loop, and you can see it's counting down, and now 0. Good. So yeah, that's how you store values into a comparator. And this will work with a power level that's higher than 15 because I don't use any redstone dust here. Okay? Now, let's go over to some more advanced stuff. So right here is the first thing that I made using some of this stuff. This is what I call a decrementer. And so what it will do is it has a value in memory, and when you put in a new value, if it's greater or less than rather, if it's less than the value then stored in memory, then it'll just keep decrementing until it gets to that value. So in memory we have power level 3 and we have an input of 3, but we can input a value of 1 by moving these down. And so, yep, it'll count down and now it's at 1. Good, okay. So that's pretty simple. All we're doing here is this is just a 5-tick pulse generator. Don't mind it, it's not anything fancy. This comparator here, it just powers this piston to keep the block up. And notice I'm not moving the cauldron up and down because if I wanted to, I can decrement by different values. I could have a, I don't know, power level 2 or whatever if I wanted to. Simple enough. Okay, so yeah, this just keeps the block up and prevents it from decrementing when we don't want to. And so the reason why I want a 5-tick pulse is because because that's how long it takes for a signal to ground in a loop. If I did any less than that, then it would just blink. So it would subtract 1 from one of the comparators maybe, and maybe 2, but the other ones their value would be unaffected because it keeps going around. And it would just go 1, 2, 1, 2, 1, 2, etc. And that wouldn't be useful. Here we have an incrementer. This is the same thing as a decrementer, except we do some subtraction. And so we have a power level. This is 15 times, this is 14 times 2 plus 1, but I just write 15 times 2 because it's easier. Okay, so we have a value in memory, and we just keep on subtracting until it reaches the required value. But the required value we're going to represent in a different way by using a high power level and then we subtract from it. Okay, so this is power level 2, and yeah, that's because the value of memory we subtract from it until it reaches 2. Let me just delete this here and let me reset this real quick. Okay, so yeah, now it's a value of 0, and we can increment to a different value. Let's put in a value of 1. Value 1. All right. 2, 3. Okay. How about 15? Simple. Okay. Now we have an iterator. What does this do? Okay, it's just the incrementer and the decrementer combined. All right, so we have our input here, and it will decide whether to increment or decrement. So this just uses two of the circuits that we have up there. So we have our input, it gets put over here, and over here we have it on subtract mode. And so if we have a value in memory, right, and if that value in memory is greater than the input here, then it will just turn this off and make sure that this cauldron is retracted. And if not, it will just extend this. And what we do here is we just subtract from a sort of inverted value in memory. So that's how we add. And how we subtract is we have a input here, and we have our value here, and this inverted value gets inverted back, so it's the real value again. And then if the input is greater than the value in memory, then we don't do anything. But if not, then we push out this cauldron, and that allows it to start decrementing. Okay, so we have a power level 0, and if I were to put in, say, I don't know, let's put a cauldron here, and let's say we want a power level 2. Okay, so what we should expect is a few pulses, since I'm a little limited on space here, can't exactly read from this if it's, yeah, it's just a little bit hard, so I just use pulse logic. Okay, so if we increment, we'll see this line here, pulse, and it will pulse twice per count. So if I were to count upward like 3 times, then it will pulse 6. Over here, it's decrement, same amount of pulses, so twice every count. So if I want to count from 6 down to 0, then we'll get 12. All right. So we have an input of 2, and the value of memory is going to be 0. Okay. Since we're using power level 15 here, I'm just going to put a redstone dot here. Okay. Don't put this redstone dot here if you're working with power levels that are greater than 15, because what it will do is it will this redstone dust will be 15 maximum. This comparator would read from that. It would override that. Okay, it's very important that you don't put this redstone dust there if you're working at higher power levels. But we're working at 15, so we don't have to worry. Okay, so this is just for the sake of the presentation. All right, let's put the block in here already. Okay, as you can see, we had full pulses. Okay. Let's decrement, and we should see this block return to its position. See? Yeah. And so, yeah, all I did here was I did a pulse divider, so divide by 2. And so, yeah, we had the block retract in, that's 1 pulse, and push back out, that's another pulse. Simple enough? Okay. I'm not going to build a tutorial for this, because I'm too lazy. But I'll just fly around here so that you can take your screenshots and copy and all that. Let me just fly under here, maybe. Simple. Okay. And yeah, that's the video. Thanks for watching. Hope you'd enjoyed. Hope you learned something maybe. Okay. See you in the next video.